Again, the production profile plotted here to the same scale, and I think we can be pretty sure that the UK has reached peak oil and has reached peak gas. And how does that peak made up? Well, the main diagram there gives an indication by field. What happens is that we tend to find and produce the large, easy oil fields first. And then they start to decline, so we bring more fields on and then more fields. And it gets to the stage eventually, not that we've run out of oil, but it's only the hard stuff that's left. And that hard half can be accessed, but to access it needs a range of other resources. First of all, it needs new technology, it needs capital, and it needs people. And they become more scarce as it becomes a more declining province. Perhaps the only country that's not short of petroleum engineers is China at the moment, China is now graduating more than half of the world's petroleum engineers. But if you were a bright 20-year-old, would you want to join this sunset industry, or would you go to another part of the world or join another industry? So I would argue that the decline that the UK is facing is not just around geology, it's around these other resources as well, and indeed the decline might be even faster than that predicted by geology. Right, just to recap, first of all, coal, our primary source globally for electricity, also a pretty important player for our infrastructure in terms of steel and cement production. Highly abundant, globally well distributed, but with the big downside of significant greenhouse gas emissions. Oil underpins our transport sector, and we've just talked about some of the challenges around the high oil prices and the limited geographic distribution. And then we've got gas. Sometimes I think a bit of the bridesmaid compared to oil and coal to increase end-use energy efficiency, either in transport or in our buildings, to increase production efficiency or to displace coal with gas, in carbon capture and storage, alternatives like nuclear and renewables, and also land use options like reforestation. And these have been quantified. So, for example, one wedge would be to build 2 million 1 megawatt wind stations, wind turbine farms. Not in addition to our coal, but by closing down the coal and building them instead. Another one would be to have 800 carbon capture and storage 800 gigawatt coal-fired power plants are fitted with carbon capture and storage. Or another one would be to double the fuel efficiency of 2 billion cars, up to 60 miles per gallon. So there they are, they're quantified, but I think we'd agree they're fairly big challenges. And what will fossil fuels do and be in this new regime? Well, I'm just going to touch very, very quickly on a few of the low emissions technologies, carbon capture and storage, natural gas and fossil fuels to liquids, and some of the Australia-specific challenges and opportunities in those areas. First of all, carbon capture and storage. I will just dance across this because I believe my colleague will go into it in more detail. Just to say that there are various options. They're all being pursued in Australia. The picture here is of a pilot plant for post-combustion capture, and indeed the first post-combustion capture pilot plant was launched just this April down in Victoria, which is capturing emissions from an existing power station. Of course, it's one thing to capture them, you then have to do something with them, and that's where CO2 sequestration comes in. Because of the scale of the emissions, a very good solution is to pop them underground. And the big challenge here is we're just starting the pilots to move up from that to upscale, reduce costs, reduce risks into demonstration and commercialisation. This is the other half of the bargain, the storage. And again, the first geosequestration pilot in Australia started again in April in Victoria. Some real challenges with this as well. I think sometimes people think maybe it's just as easy as drilling a hole next to the car park at the power station and popping the CO2 down. It's not quite that easy. There's only some parts that are suitable geology for the scale of emission injection we're talking about, the periods of time we'll be wanting to safely inject over, and of course most important of all is the requirement for surety of long-term containment. This is not going to work unless the CO2 stays down there for thousands of years, otherwise it's not a solution. So, to sum up, this is, again, some CSIRO modelling of one scenario of how we might be able to reduce emissions to 50% below 1990 levels by 2050. It's only one scenario. It's, if you like, a version of the Australian wedges diagram. We see here fossil fuels make the biggest cut. That's cleaning up fossil fuels. But it's, again, not a single magic bullet. It's a whole range of things need to be brought to bear, from alternative fuels and vehicles, reduced travel, nuclear, renewables, distributed generation, like, again, the gas turbines, etc. And last but certainly not least, energy efficiency. And then just my last slide, what can we do to make this happen? What do we do to grasp the nettle? And I think we really need to focus on our opportunities and the opportunities that will deliver the most impact. We should focus, I think, initially on our particular Australian challenges and opportunities, and I hope I've outlined a few of those. We have a number of specific opportunities around our resource endowment. And I would argue as well that we all have responsibilities in this area as well, because it's only by us as consumers and R&D providers and industry and governments working together, pulling in the same direction, that we're ever going to make this happen.